Welcome to the fifth episode of Zeroing In Season 2, the Science Podcast. I am Sean, and hosting this episode with me today is Arun S. Our guest for the day is a veteran researcher in the field of oceanography, dealing with ocean atmosphere dynamics and interaction. He completed his Master of Science in Physical Oceanography from the Cochin University of Science and Technology and went on to pursue his PhD in Ocean and Atmospheric Dynamics from the Hokkaido University in Japan. Following which, he joined the Euro-Mediterranean Center for Climate Change in Italy as a research associate. He has also held positions as a visiting scientist at the Pacific Marine Environmental Laboratory and the National Centers for Environmental Prediction in the United States. He is currently a climate scientist at the Indian Institute of Tropical Meteorology. Alongside his research, he is also a lead author at the Intergovernmental Panel on Climate Change, commonly abbreviated to IPCC, a scientific body instituted by the United Nations, whose goal is to provide information to the global community regarding climate change and its adverse effects. Recognized as one among the top 2% scientists ranked by Stanford University, our guest is on the frontier of climate change research, modeling unpredictable forces of nature like the vast Indo-Pacific Oceans and making predictions about one of the lifelines of our nation. The Indian monsoon is something he does on a regular basis. His work helps supplement humanity's arsenal of knowledge in the battle against climate change. In our conversation with him today, we get a sneak peek into the life of an oceanographer who studies the forces of weather and climate change that shape the world. A very warm welcome to Dr. Roxy Mathew Koll.
Thanks, Arun and Sean and all at IIST for this nice welcome to this Zeroing In session. And I'm really happy that you are trying to connect science with people. That's what we should do because many scientists keep science to themselves and don't take it to the public. And I'm happy that you guys are doing that.
Thank you, sir. So, I would like to start off the conversation with a small discussion about your very grassroots. So, where does this passion with the oceans and rain stem from? What were your ideas and curiosities like as a young child?
Yeah, so when I was growing up, I didn't have much idea about oceans and all. But I used to read a lot of books and reading and observing. And my parents were teachers in physics and English. So there were always some inclination to the scientific and literary world while I was growing up. But that's not where I had the fun, actually. I had fun actually reading books on wildlife. I don't know if you heard about others like Gerald Durrell. So there were these particular books by Gerard Durrell on wildlife that caught my attention most. He was a naturalist and a writer, and he used to write books on his life in the Greek. And I wanted to be like him, like a naturalist. So this interest prompted me to go out for bird watching and animal surveys when I was doing my undergrad. And at the same time, I was very much fascinated by science fiction books by Isaac Asimov, Carl Sagan, and Stephen Hawking. So I wanted to pursue astrophysics and was curious about the stardust around us and inside us. Probably it was all part of my pursuit after answers to philosophical questions in life that poke you inside while you're growing up. So, anyways, it was not the land or the space that took my passion. And I jumped from outer space to the ocean because I found that I have the right mix of science and nature in that. And though I said that we are all made of stardust, we evolved from the oceans, right? So I want you guys to take a deep breath. Yeah? Did you? Around 50% of the oxygen that we breathe comes from phytoplankton, and these are microscopic plants in the ocean. These phytoplankton also make the base of the food chain, and we know less about the seas around us that support us. So that used to intrigue me, and that is how I got into learning more about nature around us. So getting back to your question, how my formative years were and what led to what I am, I think reading and observing around had a lot to do with the way I am now.
Yes, sir. It is quite incredible that the oceans that surround us, which people take for granted, are very vital for our survival and sustenance, as you rightly pointed out. And we would like to know more about the seas and the oceans as our conversation progresses. But moving on, another aspect that you research about is climate systems and climate change. Weather being such a volatile phenomenon, how do you go about choosing what aspect of weather systems that you want to study? And what are some challenges that you face while carrying out research?
Well, yes, very much. I think, especially in India, we are almost every year now, we face challenges due to climate change. Right now, you and I, we are going through hot summer, and the temperatures are like 3, 5 degrees above normal than what we used to feel several years back. So those are the kind of questions or quantifications that I'm looking into and trying to understand how climate change is changing the temperatures around us, how it is making life difficult for us. Recently, I'm trying to getting into exploring the links with health as well, and there are extreme events almost every year. We like if you take 2020, the year 2020, we saw back-to-back cyclones. So we had a hot summer pre-monsoon period, and we were expecting monsoon rains, but we saw back-to-back cyclones, one hitting on the east coast of India and the other hitting on the west coast of India. Just 1 week difference, right? Cyclone Amphen and Cyclone Nisarga. So these kind of events make my work challenging and exciting at the same time. And it's a challenge for all of us. I mean, as humans, we all experience these kind of extreme events and the heat of climate change.
Climate does sound challenging as you're putting it forward to us now, and it's as fascinating as the research work you've done. Coming to your work regarding the warming of the Indo Pacific Oceans, which has been a recurring theme in your publications where you've observed and predicted trends like that of the sea surface temperature. Can you talk more about this work? How would you account for all the various factors that would play a role in such a chaotic system like the ocean?
So we are living in the tropics and we are surrounded by, many times we forget, we are surrounded by tropical oceans. It's not just the surface, it's deep as well. The average depth of the ocean is around 4 kilometers. Now, the interesting thing is that water has more heat capacity compared to air or land. So, which means that water can absorb more heat. It's called the property is called specific heat capacity. Yeah, and because of that, the oceans warm slower, but it holds that heat for a long time. And because it's a huge reservoir, the amount of heat it absorbs is huge. So our research shows that 90 to 93% of the heat, additional heat due to global warming, is absorbed by the oceans. And somebody made a very interesting quantification of that heat, which is absorbed by the oceans. So they say that it's equivalent to the energy from 4 Hiroshima atomic bombs every second. So you can multiply that by the number of minutes and number of hours and days for the entire period during which global warming has happened. So that much amount of heat is absorbed by the oceans. Now the thing is that among these oceans, the Indian Ocean is one of the fastest warming, or that Indo-Pacific area, including the Indian Ocean and the West Pacific region. And this is reflected in the sea surface temperatures that you were talking about. And generally, this region itself is warmer, even without climate change, even without considering global warming scenario and all. Indian Ocean is the warmest ocean compared to the other oceans. And you have to think that the Atlantic and the Pacific are open to the north and south poles, right? But the Indian Ocean is landlocked on the north. We have the Indian landmass. And that means the waters in the Indian Ocean doesn't get flushed out to the poles very easily, and the heat is preserved there, right, in the Indian Ocean. So it is already the warmest ocean, and it's also warming at a faster rate compared to the other tropical oceans. So It is changing the monsoons that we feel and see every year. It is changing the weather systems around. It is changing the way the ecosystems, the coral reefs, the fisheries all respond, right? And also, it has far-reaching impacts. So one of the key studies from our lab was on how this Indo-Pacific warming is affecting weather systems across the globe. It is actually changing rainfall patterns not only across South Asia and the monsoon, but also on weather systems that initiate from the Indian Ocean. These are called Madden-Julian oscillations. These work on subseasonal levels, but we can consider them as cloud bands which start from the Indian Ocean, move eastward to the Pacific, and then to the Atlantic. So all these kind of weather systems that even affect US and other countries also, South America, and other nations also, they are also being changed because of the intense warming in the Indo-Pacific region.
Global weather events and the connection to the entire world is captivating to say the least, and also how they affect the Indian peninsula. We would now like to talk about the Indian summer monsoon rainfall, which is another aspect of your research work along with weather forecasting and modeling. Generally, weather forecast models predict up to a week or 10 days. How do we make predictions about the Indian monsoon, or in general any monsoon, on a larger time scale, like a year or so? And what are the main challenges involved?
Mhm. Yeah, Indian monsoon is one of the strongest seasonal events on the globe. In an agrarian country like India, where we depend hugely on seasonal rains, monsoon assumes huge importance, right? Which is why we need to know when it will rain and how much it will rain. And from our scientific point of view, we are on a constant marathon to improve our monsoon forecast skills. So that is one way where we can thoroughly address these issues of changing weather and climate systems. So weather systems in the tropics are much more chaotic and complex compared to those at higher latitudes like in Europe or the US. So we have fast developing smaller weather systems, while in Europe and US, they have slow developing larger weather systems that are easier to predict. And though monsoon is a fairly organized system, it is tied to a lot many environmental variables, such as temperatures over the land and the ocean that we talked about, conditions in the atmosphere and such. So that means we need to tie up all these links, understand all these links, and put into our models. So monsoon forecasting is about making sure that these mechanistic links are present in our forecast models also. And climate models that we work on, they're like huge programs. They might be written in C language or even Fortran, and replicate the physics that we know about the Earth system. The only reason that we use Fortran in our models is because these models are built on the giants of the past. So oceanographers and atmospheric scientists have been programming these weather and climate models for a long time. And we are building upon the same models, improving it scheme by scheme, program by program, algorithm by algorithm. So that's how we end up using a mix of Fortran, C, MPI parallel programming in supercomputing machines. So we have supercomputing machines here. One of the fastest supercomputing machines in India is in IITM, where I work on. I directly work on these machines to make these climate models. So all that data that we collect over the ocean, land, and atmosphere are given as inputs to this program, which then churns out the data for the future. So we know the basic physics of how the climate works, but there are final details at finer space-time scales that are complex and hard to replicate. This comes out as the uncertainty in the weather prediction. So we are trying to work on these uncertainties and gaps in predictions and observations and improve our forecasts. In fact, we have better accuracy than earlier now. For example, we talked about cyclones, right? Like Cyclone Amphen and all. But cyclone forecasts have improved tremendously. And the lives lost due to this disaster has come down. In 1999, when I was undergrad like you guys, a super cyclone hit Odisha and tens of thousands of people died. And those were the times when forecasting was in a very primitive stage. And these are like 5-digit numbers of fatalities, right? But compared to now, the losses are confined to 2 or 3-digit numbers. And that is due to constant improvement in weather modeling and disaster management.
Yes, sir, indeed. Talking about cyclones, your most recent work or the most recent set of works, they talk about you had actually traced the reasons behind the formation of cyclones like Oki and Fani. One of which was because of the anomalous heating of the ocean just days before the cyclone actually formed. So, can this work be extrapolated in predicting similar cyclones in the future? How does this work fit in the general scheme of predicting cyclones?
Oh yeah. So I told you that cyclone forecasts have evolved with time, right? But there are new challenges that we face due to climate change. So the cyclone forecasting that has improved is based on a basic climate where it is not drastically changing. Now we see that with many of the recent cyclones like Oki or Fani or even Amphan recently, they are intensifying rapidly. And this is because of ocean warming. Cyclones draw their energy from the oceans. And the warmer Indian Ocean is assisting them to intensify quite quickly. So if you take the case of Cyclone Amphan or Oki, or some of the other cyclones that I talked about, they intensified from a category 1 cyclone. This is the case of Cyclone Amphan. It intensified from a category 1 cyclone, that's about 100 kilometers wind speed, to a category 5 cyclone, which is about 200, 250 kilometers speed, in less than 24 hours. So think about that. You are going to sleep thinking that it's a weak or moderate cyclone. And when you wake up, it's a super cyclone and it has already hit you. So it gives you less time to monitor or forecast these kind of cyclones. And our weather models are still finding it challenging to pick up these kind of rapid intensification of cyclones. So the interesting part about our study is that we tied this rapid intensification to the sea surface temperature anomalies in the Indian Ocean. And if we are able to incorporate these changes in the models accurately with better observations and with better understanding. So the problem with cyclone forecast is that many of these models do not include an actively evolving ocean. So if we include that also in this program or this model, we might be able to improve our forecast of rapid intensification.
Yes, sir. It is quite assuring to know that our prediction models are becoming more efficient day by day and that continuous work is going on to improve them. But on the other hand, it is also alarming that extreme events like this are occurring at a frequent rate. And it is not just limited to cyclones alone. We see super floods, extreme rainfall, severe drought happening all over the country and in fact the world. Do you think that this is going to be the new norm in the coming future, or maybe even get more worse as time progresses?
Yeah. So on that note, I wanted to say how, other than cyclones, how other systems are also changing. The monsoon is also changing. Our research shows that while the total amount of rainfall that we receive annually has declined over time, across most parts of India. But at the same time, while this total rainfall is decreasing, the number of heavy rains, that is in short periods, those are increasing. So that is a situation where we have long dry periods intermittent with short heavy rainfall that leads to floods. Of course, if you take the case of Kerala, we came across back-to-back floods, actually 3 years of floods: 2018 Kerala floods, 2019 Kerala floods, and 2020 sporadic Kerala floods. Right? If you look back, actually, you could see that 2015 and 2016 were actually drought years for Kerala. So these kind of conditions, drying conditions and flooding conditions, are going up. So recent climate change assessment report, our institute recently came out with a climate change assessment report for India and surrounding regions. So what this report and our own research shows that these extreme events, whether it is changes in monsoon patterns or the cyclones, they are likely to continue into the future. That means we need to monitor these changes through detailed observations and also make sure that adapting to and mitigating these changes are our priority. So it's not just cyclones and weather systems in over India that is changing across the Indian Ocean. Like there are events like heat waves, marine heat waves. If you are interested, we can talk more about that later. So all these kind of extreme events, whether it's in the ocean or over the land, they are already showing their signs of increasing, and they're going to further increase in the future. So we need to be ready now.
I noticed how marine heat waves came up while you were describing extreme weather phenomena. A serious implication that your work also talks about is the increasing frequency of marine heat waves and how it affects coral reefs, a wide variety of fishes, and the general oceanic ecosystem. Could you tell us what the consequences are?
Yeah, so that is one of the interesting research that we are doing now. It's about marine heat waves. So these are like heat waves over the land, but over the ocean. They are over the ocean. And because of ocean warming, they are popping up here and there in the Indian Ocean as sporadic events. And these temperature anomalies can peak up to like 5 degrees Celsius anomaly and can last for several days. And these marine heat waves, they can kill corals. Corals are very tolerant to warm waters. They are very sensitive to high temperatures. And corals have a soft membrane around them called zooxanthellae. And this is the membrane that gives the color and protection to these corals. So what happens is that when you have very high temperatures, this bleaches out these membranes. And when it happens several times, these corals get killed. So marine heat waves popping out sporadically here and there in the Indian Ocean are killing many of the corals. For if you consider the case of India, we have around 5 coral reef systems. So there have been corals in the Gulf of Mannar, which is in the south of Bengal, which have killed a lot of coral reefs in this region, and they affect fisheries as well. So apart from killing corals, we are finding that these marine heat waves, because these are of high temperature anomalies, right? And they last for several days. Some of them last for several weeks as well. They can, in fact, impact weather systems like cyclones and the monsoon as well. But all this research is in the primitive stage, and we are actually excited about this research. We are doing this exciting research, tracking and dissecting these marine monsters and their impact on the ecosystem and also the weather systems as well.
Yes, sir. So I wanted to ask about this research itself. You were talking about how you carry out research regarding the corals and other such bioecosystems that are there in the ocean in your lab. So how does this research go on? How do you monitor the effect of the anomalies on living creatures in the sea?
So a lot of our study uses satellite data, and that is good enough to monitor and measure environmental parameters like the ocean conditions or atmospheric conditions like temperature, humidity, rainfall, salinity in the ocean surface currents, and all. But then when we come to deeper oceans, like if you want to learn about the phytoplankton in the deeper oceans and all, we need either instruments deployed at these locations. So one of them is called the Argo. These are buoys that float in the ocean but go down up to depths of 1,000 meters at a 10-day interval. So every 10 days, they come up and send the data back to us. So these might float around the ocean. They may not have a fixed location, though they tend to be around a particular area. Now, there are another kind of instruments. These are called moorings, and they are fixed with weight to the bottom. And they have sensors throughout the depth on a cable from the surface of the ocean to the deep ocean. And on top, they also have a tower that have sensors to measure the atmospheric data. So we use these kind of instruments to measure and track many ocean atmospheric parameters, including phytoplankton also. We use to measure the chlorophyll content to detect the phytoplankton in the ocean. That's the life in the ocean. And all these data are relayed continuously from the top of the moorings or the Argo floats. And we get to use those data. And we also use models along with this data that is observed. So another way to go around taking this data is by having ocean cruises, research cruises in the ocean and collect the data. I have myself participated in some of the cruises collecting data for some of our studies.
Now that you mention cruises, it is quite remarkable, to me at least, that you were able to carry out experiments, take observations on the open sea, away from the comforts of land and a stable ground. So, how exactly were you able to set up a laboratory on a ship, and how was the experience like in general?
My first research cruise was in the Arabian Sea in 2003, I remember. It was in the month of March, and we were studying the ocean and atmospheric conditions that lead to the monsoon. So just before the monsoon, we study how the ocean and atmosphere evolve in the Arabian Sea and assist the monsoon. It was a new and challenging experience. We used instruments called CTDs. CTD stands for conductivity, temperature, and depth. It measures the salinity, temperature, and other water conditions at various depths until about 1,000 meters. So we move around in the open seas over the ship. Then we stop at a particular location which is of interest to us, and then we dip these instruments up to a particular depth. It takes several hours, and then we bring back and measure the water conditions. We also take some samples so that we can study the microscopic biological elements in it. At the same time, at these stations where we stop, we also send something called radio sondes into the atmosphere. We shoot them into the atmosphere. These are hydrogen balloons fitted with sensors that measure the winds, the temperature, and humidity of the air column above. And though we have satellites to collect data, it can't reach the depths of the ocean beyond the surface, nor it can get accurate measurements throughout the entire air column. So these cruises gave us high quality data that can help us in understanding the pre-monsoon and monsoon conditions. Now, this ship experience itself was new. We were out in the open sea for more than a month with, with about 30 other researchers. You could, in fact, compare it to the current lockdown sans COVID. Yeah. And your movement is restricted to the ship. You see the same people every day. And if you go out on the deck, you see the vast expanse of water around you, the same scene, same people. And there was no internet either at that time, which means no communication with the outside world other than a few bullet points of news that came in through the radio every day morning. And I think it was during this time that we heard about the 2003 Iraq war through these morning messages. And there was also a World Cup cricket going on that time. And we had to satisfy ourselves with 2 lines of match summary the next day. Yeah. But fortunately, there was a lot of open space on the ship deck that we used to play cricket ourselves. Yeah, but we had to stop when we lost all the balls to the sea. No, I'm joking. We were careful about that. And later, again in 2006 or 7, I got a chance for a research cruise with an American and Japanese researchers, and that was in the West Pacific on almost a similar mission. We saw dolphins jumping, and there was also some flying fishes. Whenever they see some movement in the sea, they glide. That's their evolved mechanism of escaping their predators, and they jump onto the ship. And we got to see some flying fishes with their long fins and all. That was a beautiful memory, those cruises.
Yes, sir. But then now I would like to go on a tangent and talk about your role at IPCC. So could you maybe describe what IPCC is and the role it plays in growing climate research and about your position as one of the lead authors there?
My work with IPCC, the Intergovernmental Panel on Climate Change, that assesses the state of climate change and brings out reports, it was beautiful. This is a group of experts, scientific experts in various fields of climate science sitting together, along with social scientists and economists, and finally with policymakers also, to tell the world how our carbon emissions are changing everything around us and the fine details of it. IPCC themselves bring out layman's summary of reports that go into media also at region levels. And now the big task is how national and local governments respond to it. In that note, we need to see climate change as an urgent political issue. We need to elect governments, both at local and national level, that give priority to mitigating and adapting to climate change. It's actually a bit disheartening that this is not an important election agenda, despite India facing several extreme weather events every year. But is climate change a point of discussion anywhere? I don't think so. And over 1.4 lakh people have died in the last few decades due to extreme weather events alone during the last 50 years, okay? And so it is high time that we place climate change as a priority. So though IPCC is mostly about assessing the climate change, it doesn't prescribe on what to do. That is left for local and national governments.
Speaking about taking action, while we were doing our background research, we came across this very interesting story around you and how you used embroidery to
Oh, yeah.
to better communicate with the local community. So, could you talk about that?
Oh, yeah. So my wife is a wonderful embroiderer, and she also teaches embroidery, both Indian embroidery and Western embroidery in different ways. So she also did some nice embroidery where she tried to convert some of my research ideas and research work to show how the climate is changing. And I think that's a wonderful media. You can take any media, whether it be painting or any other kind of art or different collages or even embroidery to appeal to people. Because if I go to a public stage and talk about climate change, maybe the people coming and listening to me might be only those scientifically oriented or highly educated people, right? But at the same time, there are other ways in which we can communicate science to different, diverse kind of population. And that is what we try to do with embroidery. And also, that is one artistic form where we can involve local communities as well. And there have been different initiatives from different parts of the world to include this kind of media for communicating the essence of climate change to the public.
It's amazing how artistic forms can be such an efficient means of communication. On a more personal note, how does a typical day in the life of a climate scientist look like?
Yeah. Well, so when I was a research student, I had a lot of time, I had a lot of activities, a lot of interests, a lot of things to do. I told you, right, I used to read books a lot. I used to take a lot of photographs. I used to go around. I used to go for bird watching, trekking, all those kind of activities and all, along with research. So later I got married and I have two kids now. And one thing important for a scientist is a very good balance between your family life and your scientific life. And that's what I'm trying to do. So in a day, my mornings might be about interacting with the kids or getting them ready for their school and all. And coming to office, I have to admit that these days, especially once you reach a mid-career level or a senior career level as a scientist, your days are bombarded with emails. Okay, when I talk about emails, these are also about science. This could be research queries from other students, maybe my own students, or it could be my editorial work. So I am editing certain journals, so I have to edit or review certain manuscripts, otherwise they will get delayed. I have media queries. Every time there is some extreme event happening in India, there is a cyclone going on or floods in some part of India or some other parts, discuss about it. And I like it because I want to communicate my science. So that is one part of daily routine, responding to emails. And then I get to work on my models on my supercomputing machine, which is quite a good opportunity if you get a chance. So that's also interesting. So if I end up working on my model or some experiment that I'm doing, I end up spending hours on it because it involves a lot of coding and thinking and it needs devoted time. So I spend some of my time with my students. I have a beautiful research team, well diverse research team. And we every week, once a week, we have lab meetings. So I let my lab members have casual meetings, and I let them talk about their research or their worries. I mean, so it moves from casual to scientific to casual, and so it's fun. And after those meetings, we go out for tea, have more discussions there. Those are casual discussions, of course, less scientific, and then go back home to my kids and my wife and have time with them. Those are the ways how I spend my work days. Yeah.
As you've mentioned that you've reached a mid-career part in your life, going forward, how do you think your research directions, as well as ideas in general life, would evolve over time?
Yeah, truly speaking, there are a lot to explore in science. I'm consistently looking for vistas where I can investigate how the climate is interacting with this world. For example, every monsoon, the birds, butterflies, and dragonflies, they migrate from Africa to India, and then they return to. And this route is called the Great Indian Ocean Flyway, where they travel from Africa to India and back. Sometimes they go up to China and come back. So, how do the winds and the weather systems assist them during their flight? Are there year to year changes in the monsoon reflected in their numbers and the time they appear, these birds and butterflies appear? Is it getting affected by climate change? These are interesting questions. Now, Citizen Science Network, you might be aware of, they have a lot of data. So, like the eBird initiative, eBird data, that has brought in a lot of data now. And COVID gave me a time where I listened to webinars and insights from naturalists using this data. So I'm eagerly looking forward to work with these biologists and naturalists. Yeah, that is one direction I am looking forward to. Another one is to see how the changes in climate and monsoon is affecting the health conditions and spread of diseases in our cities. So we have several challenges. One being that the study is transdisciplinary. It is not just with weather systems, but you are dealing with health also now, right? And the other issue is being that health data is hard to get because many times these hospitals or municipalities don't record the health data or digitize them properly, and they are sensitive to the data because of many issues, and they don't want to, because it involves mortalities also, so they don't want to divulge that information. But however, we are all making some small but gradual strides in our understanding. And if you are able to model the links between climate variables and certain diseases, we can use that to predict how health conditions will be in the future. And then the administration and health department can take precautionary measures based on that, right?
Right, sir. These research avenues sound very promising and, in fact, quite ingenious. On the same flow, did you have any directions that you wished you had worked on but couldn't? Say, an alternate career path, something that you would have done if you were not doing what you're doing now.
Well, there was a time when I wanted to be a philosopher, and there was a time when I wanted to be a writer. I like art, but never became an artist. But I tried to have some creativity when I tried to make my figures for publications and all. I tried to put in some creativity in there, whether it's my writing style or drawing style or something like that. I used to be an amateur photograph. If you go to my one of my websites, you can see some of my old photographs. Well, now I'm not taking that many photographs, but I used to focus on nature photography, like particularly macro photography, even birds as well. I made some articles and used to post on my website. And in fact, recently, the National Geographic, they approached me for a photo that I took and posted on the blog. It was of Baya weavers. It was taken just outside the quarters that I'm staying in a few summers back. And it's a Baya weaver stitching its nest. So that's a beautiful photograph. And they wanted to use it in one of their publications, one of their educational publications that's going to be printed soon. So in case I get fired from my job, I can I still have something else to do, right? Yeah.
Yes, sir. We hope that does not happen anytime in the future.
Really.
So, sir, is there anything you would like to say on a concluding note? Anything that you wish to say?
I think what we are doing now, communicating science to public, and that is something I have found increasingly important for me through my evolution as a scientist. One has to communicate science to the public. Whatever research you do, you should not stop at publishing papers, because we might get rewarded with publishing papers from our institution or something like that, but publishing, it's only a starting point. You have put it out there. Then the task is to bring out the salient points of the research in a digestible way for the public to consume. And that is an important step for progress in science, I think. Another important aspect that I think is to have diversity in science. It can be in terms of gender, region, or age. And simplistically speaking, we need more women and youngsters leading scientific research. India still looks up onto hierarchy and bureaucracy based on seniority, as in number of years that a person has worked, or but we need to give more opportunities for youngsters and women from different regions. That will bring out so that they can come out and exercise their ideas. That will bring out big, huge perspectives. That will bring out innovations, and otherwise we won't grow.
This was Zeroing In with Dr. Roxy Mathew Koll. We would like to extend our heartfelt gratitude to Dr. Koll for taking time out of his schedule and sharing his beautiful experiences and journeys with us in his field of oceanography and climate change research, along with KVNJ Vikram for collaborating on this episode. On behalf of the Zeroing In Season 2 team, which includes Murala Aman Naveen, Shreya Mishra, Kriti Raj, Kantan Narayan, Arun S., and I am Sean. Thank you for listening to this episode. Zeroing In is a non-profit initiative by the Indian Institute of Space Science and Technology Alumni Association, Thiruvananthapuram. Do write your suggestions and feedback at zeroinginpodcast@gmail.com or contact us on our Instagram or Facebook handles.